This is a homework help video for the Trig Unit 5, homework number 3 on linear and angular speeds. I'm going to work a few problems throughout the worksheet to help you guys out. So we'll start with number 1, where we're just trying to find linear speed, and our goal is to be in inches per minute. We're going to use the information given where the radius is 12.5 inches of our tire. And we go 545 revolutions per minute. So we're going to start with our formula for linear speed, which is going to be, let's see. So the formula for linear speed is V equals S over T. S is the arc length and T is the time. And so we want to go ahead and find the arc length. So the arc is how far that tire has traveled. So it's actually in a minute, it has gone 545 times around. So remember, S is r theta. So we've gone 540 times around, and each time around is 2 pi. So I'm actually doing, this is the theta, this is how many radians it has traveled, and then the radius, I can go ahead and multiply by 12.5. So I did theta r instead of r theta. So I get, my arc length is 13,625 pi. And it seems like a lot, but it is a tire, and that's how many times it goes around. And when I want to find my linear speed, then I'm just going to take that arc length, and that is per minute. So these are inches, and that is per minute. So we're going to do something similar with questions 3 and 4. This is a fan on a pool heater with a diameter of 107, and it goes 212 revolutions per minute. And this time, let's go ahead and do the angular speed. So I want to keep my angular speed formula handy, and that is omega equals theta over t. So the theta is the central angle, and the t is the time. So again, we want to be able to find out how many radians has this fan traveled. And so we're going 212 revolutions. Each revolution is 2 pi. So it has gone, so this isn't for my omega. This is just finding my theta. My theta is 424 pi. And then it has gone that far in 1 minute. So our final answer, if we just multiply the 424 and the pi, we get 1,332, and that's radians per minute. So let's take a look at some of these other problems. They're really just kind of mixing together the linear and the angular speed. So what would be a good one? Let's go to the back side of the page. And let's look at number 9. The wheels on Darlene's car have an 11-inch radius. They're rotating at 378 RPM, so that's revolutions per minute. We want to find the linear speed in miles per hour. So I can already tell you if we have inches in our radius and we're trying to get to miles per hour, there's going to be some unit conversion involved here. So let's start with our formulas, and we've got let's see, we're just finding linear speed. So that is going to be the V equals S over T. And the S is the arc length. So I'm going to use my S equals R theta, which is the radius is 11 inches, and the theta is your 378 revolutions per minute times 2 pi radians per revolution. So that is going to get you 378 times 2 pi is 756 pi, and then times 11 is 8,316 pi, and that's inches per, and then we can just do the divided by t, which is per minute. But they didn't ask for inches per minute. They asked for miles per hour. So we're going to use some dimensional analysis, and we're going to put our number that we're starting with, and I want to end up with miles on top and hours on the bottom. So I'm going to, in Algebra 1, I kind of teach this railroad track method. I'm going to put all my unit conversions. So I know I don't want inches in my answer, so I'm going to end up with inches on the bottom of something. So and I know how many feet are in a mile. So I'm going to say 1 foot is 12 inches. And then there's 1 mile has 5,280 feet in it. So that's going to help me get to where I have miles, and it's going to get rid of my inches and feet. And then for minutes, I want to end up with hours on the bottom. So I'm going to say 1 hour has 60 minutes. And I think, and here's how I know I'm going to end up with the right units. My units will cancel, and maybe you've seen this in science class, or here's a minute on the bottom and a minute. So the only units left are miles and hours. And once you multiply those out, you'll get to where you need to go.